everyone can keep talking for a little bit. We're just waiting on one of our discussants. We'll start in a little bit. Okay, well, I think we're going to go ahead and get started. I want to welcome everybody to the 2016 Joint Program and Survey Methodology Distinguished Lecture. My name is Brady West. I'm a research assistant professor at the Michigan Program and Survey Methodology and also here at JPSM, and I'm very happy to be here with everyone today. I'm particularly honored to be stepping in for Jill DeMattis, formerly Montequilla, who is chair of the committee that organizes the Distinguished Lecture, and that includes myself and Sung-Hee Lee. Jill was unable to be here today, but we really want to thank her for her hard work in organizing this lecture and leading this committee. We also, as a committee, want to thank Jody Williams for her extremely hard work in putting this all together and working on the logistics. So let's give Jody a round of applause, too. This lecture is being shown on a live YouTube channel, so it's being streamed live, and that's being viewed at multiple sites. What we're going to do this year is have viewers at remote sites, including people here. You can do this as well. You can text questions to a particular phone number. I'm going to show that phone number up on the slides right now. It's 301-892-3211. You should also see it on this half page that everybody got, the flyer for the Distinguished Lecture. So at any point during the lectures, if you would like to text a question for one of the speakers, please send that. I will then get those text messages and I will communicate those questions. We'll probably alternate back and forth between the sites when asking the questions when it comes time for question and answer. Please do hold any local questions until the end of the lecture and the two discussants have been able to speak as well. And then we'll have a question and answer session. There's also going to be a reception following the lecture in the atrium of the STAMP Student Union where we are right now, which is really just the back of this room. So please feel free to stay with us, and we'll have some more discussion after the lecture's over. So I want to start by first introducing our distinguished discussants. First of all, Rick Valiant. He is a research professor at the University of Michigan and the Joint Program and Survey Methodology here at Maryland. Rick has over 40 years of experience in survey sampling, estimation theory, and statistical computing. Rick was formerly an associate director at Westat and also a mathematical statistician with the Bureau of Labor Statistics. He has a range of applied experience in survey estimation and sample design on a variety of different establishment and household surveys. He's also right on time. And he's also a fellow of the American Statistical Association, and he's been an editor of several different statistical journals, so very distinguished career. We are sad to be losing Rick to retirement in December, but as those of us working in survey statistics and methodology know well, no one ever really retires. So we'll look forward to Rick's contributions for many years to come. Second, Cynthia Clark. Cynthia retired in May 2014 as administrator of the USDA's National Agriculture Statistics Service, or NASS, and she oversaw that agency's efforts to collect and disseminate data on every facet of U.S. agriculture. Cynthia is an accomplished statistician who is highly respected both in the U.S. and overseas for her expertise in survey research and development. Before joining NASS, she directed statistical research and survey methodology for the UK's Office for National Statistics, and prior to that, at the U.S. Census Bureau. She's also served in numerous professional positions with the ASA, the International Statistical Institute, and the International Association of Survey Statisticians. Additionally, Cynthia is a fellow of the ASA, an elected member of ISI, and a fellow of the Royal Statistical Society. Her focus has been on research in survey and census methodology, confidentiality and privacy, statistics education, quality management, computer-assisted survey methodologies, and official statistics, including economic, environmental, demographic, and agricultural. Since retirement, she and her husband served until October 2015 as missionaries and historic interpreters in historic Nauvoo, Illinois. Am I saying that correct, Cynthia? No, okay. A community that's been restored to its 1840s vintage. Since returning to the DC area, she's now serving on a National Academy of Science panel re-engineering the Census Bureau's annual economic surveys, the Statistics Canada Advisory Committee on Statistical Methodology, and on the board of the Council of Professional Associations on Federal Statistics. So like I said, nobody ever really retires. She received a bachelor's degree in mathematics from Mills College in California, a master's degree in mathematics from the University of Denver, and master's and doctoral degrees in statistics from Iowa State University. She was recognized in 2014 by Iowa State as a distinguished alumna. She and her husband Glenn are the parents of 6 children and grandparents of 20. I was fortunate to first meet Cynthia through the JPSM Junior Fellows Program, and she's truly had a profound impact on the careers of numerous survey statisticians, including myself. And now I want to introduce our speaker for the distinguished lecture. Sharon Lohr joined Westat in 2012 as vice president after a 25-year academic career, most recently as Dean's Distinguished Professor of Statistics at Arizona State University. She's the author of the book Sampling, Design and Analysis, and has published numerous articles on survey sampling, hierarchical models, missing data, design of experiments, and applications of statistics in the social sciences and education. She is a fellow of ASA and an elected member of ISI. Dr. Lohr has received the Gertrude M. Cox Statistics Award and the Morris Hanson Lecture Award, and she was selected to give the Deming Lecture at the Joint Statistical Meetings in 2014, which many of you probably attended. Sharon's going to have up to 1 hour for her lecture, and each discussant will then provide comments for no more than 15 minutes. I'm going to give a 5-minute warning to each speaker, so I'll sit here in the front row. And then, as I mentioned, we'll have time for questions at the end. But again, if at any point during the lectures you have questions that come up that you'd like to ask, please text them to this number, and I'll make sure to relay them during the question and answer session. So at this point, without further ado, I want to turn it over to our distinguished lecturer, Sharon Lohr.
All right, thank you very much, and thank you for that kind introduction. There's the number. I was reading a paper on big data, and I saw these entries in the bibliography. And my first reaction was that little thrill you get when you see your name and you think, wow, somebody cited me. And then I looked a little more closely, and I thought, I don't remember writing anything for the New York Times. And it turns out this is not me. This is a reporter for the New York Times named Steve Lohr. And so I read Steve's book. It's called Dataism. And as I was reading it, I thought, there seem to be some topics that are not covered in this book about data. So here's part of the index from S. And can you tell me what words seem to be missing here? Just shout them out. Statistics, anything else? Sampling, surveys. Right, it's interesting, all of our words are S words, like Sharon. Yeah. And then I looked at some other big data books, and they don't mention them either. We don't even make big data for dummies. But I did find one book that did mention sampling, and here's the quote. So is this right? Is sampling kind of obsolete? Are survey statisticians like the blacksmiths of today? So to look at that, I'd like to revisit where we are today and compare that with where we were when probability sampling was just getting started. So here's the list of advantages and disadvantages of sampling from Mildred Parten's book. And there are similar lists in the books by Deming and Hansen and other people who were writing at the time. So the advantages of sampling that she mentions are threefold. First of all, you can get faster and cheaper estimates because you don't need to conduct as many interviews. Second, you can tailor the data collection to your research needs. And you can pay attention to problems such as measurement error and non-response. And third, and this point is hit very heavily in Deming's book and Hansen's book, is that if you're doing a probability sample, you can design so that you get the precision that you want. Right. What are the disadvantages? Well, sampling is hard. And I think this shortage of sampling experts that Parten mentions is certainly still valid. And then the other disadvantage that she mentions is that you just don't have as big of a sample size. So you don't have information in the survey on things like rare subpopulations. So how do those advantages and disadvantages hold up today? Well, I think the disadvantages are still there. But some of the advantages have diminished, I think. Data collection from other sources is often faster and cheaper, and some of the costs of probability samples have gone up. The idea that we can design to get a certain precision, I think, has also changed a little bit, right? Because we can design to get a certain precision for the sampling error, but much of our error comes from non-response and other non-sampling errors, and we don't necessarily know whether we're going to capture the precision that we want from our survey. So I think we need to view the role of a survey statistician in the holistic way that Deming viewed it. Not as someone who just takes part of the sample and part of the data instead of doing the whole thing, but as someone who designs the entire data collection so that it will answer the research and policy questions of interest. And I think we want to pay special attention to the second part of his quote here, where we want to use probability theory to be able to measure the reliability of the information that we get. So how certain or uncertain are we in the estimates that we produce? So in my talk, I want to focus on three features of survey statistics that I think are essential as we go forward. So these are things that we use all of the time. They form our worldview. And the committee that invited me to give this lecture asked me to talk about what I see as research problems for students. And so for each of these features, I want to mention some things that I think are areas where research is needed. And some of these I've worked on, but I saved all of the hard ones for you students. And then to end the lecture, I would like to revisit what may be the most famous survey sample of all time and see what that says to us now. So I'd like to talk about survey design in the context of the National Automotive Sampling System. So this system has two components. The first component is a stratified cluster sample of about 50,000 to 60,000 police accident reports. And in this sample, more serious crashes are sampled with higher probability than crashes that are just fender benders. The data that are collected from these, they're basically transcribed from the police accident reports. There's no further investigation done for these. The further investigation is done in the second component, and that's that crash investigation sampling system. Whoops, there it goes. Let's go back. Hang. There we go. All right. In the second component, trained investigators go to the sampled crashes. There's about 5,000 police accident reports sampled for this thing. They interview the people involved and the police officers. They inspect the wreckage. They get permission to access the medical records. And they're investigating in depth some of the features that may have been causative factors in the crash. So these data are used for a lot of research on the relationship between features of vehicles and traffic safety. They're used in thousands of research reports. I just put 5 of them up here. And you can see they're involved in a lot of research on how traffic safety can be improved. But my question is, what if we were starting over? What if we didn't have this structure already for the survey and we could design it anew? And I want to emphasize here that this is my fantasy. This has absolutely no relationship to any plans or any work for this survey. So the first thing is I think that we'd want to have a uniform data collection. We'd want to be collecting the same information from the different jurisdictions about the crash. And there are guidelines for this, but they're voluntary and not everybody follows them. And the second thing is, for that first data component, since it's mostly just a transcription of what's in the police accident reports, why wouldn't we want to get all of them rather than just a sample? Right? And again, it would take some time and investment to get this set up, but once it was set up, the data collection would be pretty much automatic, and you'd be capturing all of the accident reports, and you'd have much faster statistics from this. I think the big advantage is that you would be capturing all of the small subpopulations, because a major factor of interest for this survey is you'd like to be able to see if, for this particular subgroup of vehicles, if there's more risk of serious injury, for example, with this particular safety feature. And so if you had all of the data, you could look at that. So if we did that, if we had this census, we had our dream system here, then what's the role for survey statisticians? Well, there's always going to be non-response, and so we can, adjust for non-response. But I think that having this rich, dynamic frame really opens up a lot of areas for innovation in survey design. First of all, for the police accident reports, which are now going to be uploaded electronically in real time, we would want to have some sort of audit to verify the quality. And so there would be a sample design for that. But I think the real gain would be in the sample design for that second component, the one where the investigators go out to the crashes and do this in-depth study of the factors. And I think one way to do that is to have more research in balanced sampling. And balanced sampling is used in Europe. It's not used as much in the United States, although there's been a lot of pioneering research done on it in the United States, and in particular by Rick. So this is where I'm supposed to put in the plug for Rick's book. So, right. And so in balanced sampling, we would have a very, very rich frame. And this would be the sort of thing we would have if we got all of those data elements in the Uniform Police Accident Report. And we would set up the survey design so that it is representative on all of these features. So for example, you would have the estimate of the number of rollover crashes from your sample would equal the number of rollover crashes from the sampling frame. Same thing, you would have your estimate of the number of crashes involving children who are injured would equal the population number. And you have this for hundreds of different variables. in here. Now, we do this all the time anyway. Stratification is a special case of this. If we stratify by sex, then the number of women that we estimate from our sample is equal to the number of women in the population. It's just that with balanced sampling, you can do it for a lot more variables, and you have a lot more flexibility in how you do this. And I think that this raises a lot of research problems. There's been much work done, but I think there's more to do here. And so a balanced sample is a probability sample from a set of possible samples that satisfy the balancing constraints. And so if you have this rich of a frame, what if you have only a few samples that satisfy those constraints? Or what if you don't have any that exactly satisfy them? And so in some cases, you can do a model-based analysis, but if you're using too much information from the frame, at what stage do you cease being a probability sample? And what do we do then? So I think there's some work to be done in estimating uncertainty for these surveys, and in particular, when we're kind of verging on being almost a deterministic sample in here. The other thing that I think we need to work on is we have a dynamic frame. And so we don't necessarily have to stay in our current model where we collect the data, we weight the data, and then 2 years from now we produce an estimate from the data. We can start producing moving averages from these data and have statistics that are produced that are useful now and reflect current conditions. And this, I think, is going to require a lot of research, because I think that we want to do something where we can weight as we go and adjust the properties of our sample as we go while still maintaining a sort of continuity in there. So I think we're moving to a situation where some of our frames are going to be incredibly rich. So like my fantasy motor vehicle crash frame, credit card transactions, sensor data, right? Data from cell phones. We have a lot of information from these. And then on the other hand, we also have relatively inexpensive sources where we don't have that much information. Internet surveys, convenience data sources. They have incomplete coverage. Sometimes the coverage of the population is unknown. And for these, I think increasingly we need to look at combining data sources to answer our questions of interest. So here's a picture. This is a population, all right? And here's a perfect probability sample. And this is the kind of sample that most of our theory is based on, all right? So this particular one happens to be a 5% simple random sample. And this is wonderful for population estimates if we don't have any undercoverage or non-response or measurement error. Someday, I'm hoping that I will see something that is close to a perfect probability sample. I haven't yet, but there's still time. All right. But the drawback of this is that there isn't a very big sample size for the subpopulations. Right? So we're great for estimating the population as a whole. If we're interested in subpopulations, we just don't have that sample size to do that. Here's administrative records. So for example, this might be electronic health records, or it might be tax data. And these are incomplete, but we might know what subpopulations are missing. So for tax records, we're missing people who don't file taxes, right? Okay. But they're not necessarily collected for the same purpose. They don't necessarily ask questions that we would like to have answered. We don't always know the quality of these, but they are a valuable resource for estimation. And if we take the Deming-based holistic view, we'd want to consider using these in our estimation. And then we might have a non-probability sample or a convenience sample. So maybe something like data from social media in here, data from Google searches. And the question is, who's there? We might have the same people in the data set multiple times, and we might not know how many times they're in there. And they also might be kind of distorting what they're saying. For the tax records, I mean, some people might be distorting what they're saying too, but they would probably distort it on all sources, all right? So we want to look at approaches for how can we combine the information from these different sources to improve our estimation. So if you can do it, a lot of people are looking at linking records. In this talk, I want to concentrate on multiple frame survey methods. So in a multiple frame, this is a 2-frame example, we have 2 sampling frames. So, and here I'm showing the population for frame A. This might be the frame for, say, an in-person survey or for a telephone survey, and it's pretty complete. It covers pretty much everybody in the population. There's a few omissions in here. Frame B might be incomplete. So it might be our electronic medical records, for example. Right? However, we may be in the situation that the information from frame B is really inexpensive to get. And in some cases, we may actually have everybody in there. We may have all of that data for frame B. In other cases, it might be just that we have a list of part of the population and then we can do a sample of them. And so we're assuming that we don't know for the population who's in both surveys. So we may be taking independent samples from each of these. So from our telephone or in-person frame, we take a probability sample. And in this case, I'm showing a census from frame B, that we're going to just use all of the records in there. All right? Another application of these dual frame samples, we've seen these in a lot of the polls lately. They do a dual frame survey where one sample is from the landline telephones and the other sample is from the cell telephones. And then they put those together so that they can get the entire population. Now, we can't just put the samples together because there's some units in the population, in the samples, that could be sampled from both places. And so again, let's go back to our population. We don't know this, but you can think theoretically of dividing this into 4 pieces. So the upper left plot here, this is the part of the population that's in frame A, right, our almost complete frame, but they're not in our electronic health records. The upper right is the part that's in B, but not A, so maybe non-telephone households. All right. The part at the bottom left is the part that's in both. And for this, we need to do some sort of compositing to put these together so we don't double count these people when we're adding it up. So if we're looking at the population total, right, we might take a weighted average of the total that we get from the frame A sample and the total that we get from the frame B sample. Right? And for this example, if our frame B information is good enough, we have so much of it, we might not even need to rely on the frame A sample for this. Right? And then there's the bottom right, which we really don't know much about from our survey. They're not in either part of it. So we don't need to know who's overlapping in the population, but we do need to know who's overlapping from our sample. And so from the frame A sample, we need to know, are the people who responded to this also in the other data source? And so after you collect your sample, it might be possible to link records. You might have their name and address and be able to link it to the records. Or you may be able to ask people questions in your survey to help determine if they're in the other source. For instance, asking them about their medical usage in the past year, asking them about their insurance coverage, things like that. But you need to find out somehow from the sample how many of those sources they're in. You also need to do that for the other data source. And for this one, if it's actually administrative records, we can't necessarily control what questions are asked for that. And we might not be able to know that. And we might just have to kind of try to adjust for that in our non-response adjustments. So what's the problem here? The problem here is bias. right? If there is no bias in either source, both sources are estimating the same population quantity in that part where they're overlapping, then combining the data sources is wonderful. It reduces the sampling error because it increases our sample size. It also gives more information on the subpopulations, at least in that part where we have both of them. Right? And it improves coverage because from the A survey we get the information that's not in the other one. And this is the main use of dual frame surveys in the cell landline, because you want to make sure that you get cell only people and you want to make sure you get landline only people. So that improves your coverage. But the problem is that if you actually have bias, combining sources can make things worse than if you only used one of them. Right? And moreover, if you use our standard formulas for the standard errors, those are much too optimistic and they don't reflect the true uncertainty about the estimate. And I think it's the general form of these things that often when we do these dual frame surveys, we have different modes, we have different non-response patterns. If we're combining administrative data, we have different questions. And so there is a lot of reason to believe that there may be differences between the two sources that are not merely the sampling error differences. So Mike Brick and I looked at this by dividing that overlap part into subpopulations. So we did this in the context of combining information from the National Crime Victimization Survey with information from a low-cost mail survey to try to get better subpopulation information. And so we assumed that our first source is unbiased. Right, so we assume that that is the thing we want to estimate, but we just don't have the sample size in some of the subpopulations to be able to get an accurate estimate. But we can use that subpopulation information to evaluate the differential bias from the different sources. And so we combine the estimates and we depend more on our gold standard source for the subpopulation estimates. First of all, if we have a large sample size from that gold standard source, because then we have a lot of reliability from that particular estimate. Or if the other source has a large amount of unexplained mean squared error. So that means we have a lot of bias that we can't explain. And what I mean by that is the differential bias that varies by subpopulation. Right? Because if every subpopulation, if we're 3 percentage points too low, well, hey, we can fix for that. You just add 3 to everybody. But if some of the subpopulations have bias in one direction and some of the subpopulations have bias in a different direction, then how do we adjust for that? The last feature of our method is that the mean squared error captures that bias as part of the uncertainty estimate. So let me show you a picture here. All right. This is a simulated data set, and the confidence intervals here are constructed using the sampling error from both of the sources. Right? They're independent sources. It's easy to construct a confidence interval for the difference. Both of the estimates have been pre-calibrated before we look at this interval. They've been calibrated to independent population totals in here. So when you look at this, it appears here that we have a lot of differential bias that's not explained by the sampling error. And so for this would be telling us that if we have areas where we actually have no information from our gold standard source, we would want to have very, very wide confidence intervals for an estimate that's based on our second source, because we just don't have a great deal of faith in this particular model for it. And so that lack of certainty here about how our estimate from source B corresponds to source A, after we've done everything we can to model it, that's going to be reflected in the width of our confidence interval. I want to mention here there are a lot of other methods out there for combining estimates. Almost all of them, if you look at the asymptotics, so even the most complicated hierarchical Bayesian method reduces to basically a weighted average. of the two sources. And the problem is, how much do you weight the different sources, and how do you do the measure of uncertainty? And so a lot of them, they do basically the same thing. They try to model the bias, and then that bias goes into the measure of uncertainty. But I think there's a lot of research to be done in this area. And particularly when we do have some differential bias, or we're worried about differential bias. All right, so Mike and I, we assumed there's a gold standard, and you can use that to evaluate the bias and to adjust for it. But what do you do if you don't have that? And that's true if we're combining a lot of data sources and we don't have the high quality survey. So we don't have NHANES, we don't have the National Health Interview Survey to do this. All right? So some people average the different biased sources in here. And you can do that, but then your population parameter is basically depending on whatever sources you happen to have. It's not really well defined in advance. There are a number of Bayesian approaches where they put prior on the bias, but in the absence of some sort of gold standard for at least part of the population, that's going to give that prior estimate right back at you at the end of it. So I think this is a big problem that needs to be looked at. How to combine these estimates, how to account for this bias in there. We also have problems to look at here for design, because with all of this wealth of other information out there, I think we can design our surveys to be more efficient, to take advantage of these other sources. And we also don't have to use the same method for combining data for all of our subpopulations. So for example, we might be able to link records in the subpopulation of people aged 65 and up. Right? We might have information about that, and we might have to just combine the other summary statistics for other parts of the subpopulation. We also want to be able to design the survey so that we can evaluate the other sources. We can determine the source membership, so we know how many of these frames they're in. And there's also a lot of work to be done in here in weighting. All right, I talked about using the weighting to combine the sources. We also need to weight to do the non-response. And we also need to account for what happens if we get the source membership wrong, and we want to be robust to that. So here's our picture, right? We have 4 sources here, and some of them are spottier than others. And we want to design our sample or multiple samples to try to complement the sources that are inexpensive that we can take advantage of, and so that we can evaluate the quality of those sources and make use of them in our data collection. Right. Okay, third topic. The law of total variance is not some arcane secret that's known only to survey statisticians. But we do use it a lot. And all of you students have used it to derive the variance for 2-stage sampling and for 2-phase sampling, where we condition on either the first stage units or on the first phase units. But here's an area where we don't use it, and that's in post-stratification and calibration. So again, calibration, we're adjusting the weights to compensate for non-response. And so what we do is we multiply the weight in each poststratum, this subpopulation, so that some of the weights in that poststratum, after we adjust it, is our independent population count, which we assume is known from a really, really, really reliable source. Right? And then to estimate the variance, we use the variance of the estimated total of the residuals from this particular model that we're using. So if we have 100% response rate, this is wonderful. That variance is fine, all right? But that variance is calculated under the assumption that the post-stratification removes the bias. And so our inference is really conditional on the model that we use to adjust the weights. And that's where our law of total variance comes in. So what we report is the first part in there, the variance of the expected value given the model. right? And we don't look at the variability that's due to the second part, our model uncertainty. And Delineus wrote about this, and he used the wonderful phrase that we strain at a gnat and swallow a camel. And so he said that survey statisticians fixate on this gnat of sampling error, and then we ignore the big camel of the non-sampling error. And as we have bigger and bigger and bigger data sources, our sampling error is really going to zero. That's not a factor anymore. All of our error is the non-sampling error. But currently, we don't include it in our measures of uncertainty, for the most part. So this is my third big area where I think we need research. We need a better measure of uncertainty, and I think we need an industry standard for agreeing on this measure of uncertainty. Right? And there have been a lot of polls kind of mentioned lately. I don't know if you've seen any of them. It's hard to avoid if you've turned on the news, right? And and most of these polls, they have a footnote at the bottom somewhere that says margin of error is plus or minus 4%. And then some of them have an even smaller footnote to that footnote that says, oh, that's actually the sampling error only. And it depends on these really big assumptions. And if those assumptions aren't met, then we're going to be more inaccurate than that. Right? And so if you look at the guidelines for surveys in things like the principles and practices of a federal statistical agency, right, it is strongly recommended that you do sensitivity analyses, error profiles have been popular in the past, and that you look at potential non-response bias for your survey. But none of these make it into the margin of error that we report, and I think that needs to change. Right? The essence of our discipline, the discipline of statistics, is that we do variance. We do confidence intervals, and those confidence intervals include our uncertainty. And we're not capturing the biggest part of the uncertainty right now. So I want to talk about one thing that I've been working on for this, and this is not a complete solution. There's lots of room for lots of dissertations in here. But this is for the situation where we have auxiliary information from the sample that we can use to evaluate non-response bias. And sometimes we can get this auxiliary information from other sources. For example, if we have a mail survey, we might know characteristics of the census blocks where our addresses live. So we have a matrix X, and this is the information that we've used for our post-stratification or for our raking or our inverse propensity weighting or whatever method you've used to adjust for non-response. And then we haven't always used all of that information for adjusting for non-response. So the matrix A is the extra variables that we haven't used. Right? But a lot of those are correlated with the variables that we have used. So for example, we might have raked to marginal totals based on age, race, sex, and then we have the cross classifications of those as our extra information. But that has been partially adjusted for by our adjustments for X. If we've adjusted for education, we've also partially adjusted the occupation information for non-response. So I want to look at the matrix T. This is a part of our extra information that's orthogonal to X. And so then we can write our response of interest Y as a sum of three parts. It's the part that's predicted by the information we used in post-stratification, the part from our extra variables that's orthogonal to that first part, and then there's the part we don't know anything about. These are the unknown variables. All right. So here we are again, and I want to concentrate on the part in the middle. So this is basically the projection of our Y variable onto this extra auxiliary information. Right? And so we can find this regression coefficient, at least using the respondents, and we can find that predicted value of that middle part for everybody in the selected sample because we know this information for everybody in the selected sample. And then once we do that, we can compare our estimated population total or population mean for this quantity using everybody in the selected sample. And we can compare that with an estimate of the same quantity from the respondents only after we've adjusted the weights for non-response. Right? So what this would do then is the difference between these two estimates is at least going to give us some measure, a partial measure of some of the non-response bias, and it's taking into account a lot of this extra auxiliary information in one measure. And if we want, we can incorporate that into our uncertainty measure for that particular quantity. Now, there are a lot of challenges involved in this. For one thing, you can claim you don't have any non-response bias just by not collecting any additional information, and then there's nothing to test, right? The big problem here, of course, is what about the unobserved variables, the U part that we don't know? And I think there is a lot of research to be done here. I think Bayesian approaches are promising for this, and a lot of this has been done in risk assessment in here, where prior information is put on to express uncertainty about the different models. Maybe we can do some sort of multiple imputation with different models. Using multiple sources can give some information about potential bias, right? Or at least we know that some of them are biased. We might not know which ones, right? Okay, but I think that's a big problem to work at. And so I'd like to conclude this lecture by going back to what I think is probably the most famous sample in history. If you ask anybody to name a bad sample, chances are that they're going to give you this one. Or at least that was true until this week. All right. So 2016 is a really important anniversary for us. This is the centennial of the first Literary Digest poll in 1916. All right. And you probably know this story, right? Because this is the most famous sample ever, right? So they had a sampling frame based on their subscribers and constructed from lists of telephone owners and automobile owners. They sent out 10 million ballots. They got almost 2.4 million of them back. And by a lot of today's standards, that's actually a pretty good response rate, all right? The poll predicted that Landon would have a landslide victory in 1936. This was in the October 31st issue. And in reality, we don't learn about President Landon in our history books, right? Roosevelt carried every state except Maine and Vermont, and he carried them by big margins. And it's thought that as a result of this polling error, the magazine ended up shutting down in 1938. All right. So here's the ballot that was sent out to people in 1936. And it's actually, they collect information that would be useful here. If you look behind the word use, right, it says mark how you voted for president in 1932, all right? And then they list the 3 candidates in there. And so in 1936, the Literary Digest people would have known how many votes were recorded for each candidate in 1932. And this was true even though they didn't have Wikipedia. So you ask, well, why didn't they weight the data? And in fact, all of these techniques were known then. They knew how to weight the data. The very day that their poll appeared, there was an editor to the a letter to the editor in the New York Times. And it talked about all kinds of different methods that could have been used to weight the data. You could have weighted by the bias in the previous years. You could have weighted by the previous election results, et cetera. Right? And it went on for a long column. It was proudly signed, amateur statistician. Right? So what happens if we weight? What I did here is just a simple ratio adjustment by how they voted in 1932, and I did get the 32 returns from Wikipedia, but all right. So on the x-axis here is the actual percent vote for Roosevelt, and then the y-axis is the predicted. And so the left panel here, this is the unweighted results, and you can tell that they're way low for every single state. The blue states here are where they got the correct winner. The red states are where they called that state incorrectly. All right. If I do my ratio adjustment here, it's still off from the 45-degree line where I'd want to be, but enough states move over that 50% line, including New York and California, that had they weighted their data, they would have predicted that Roosevelt wins. I also looked at this. I did kind of a Bayesian analysis, and I did some measure of uncertainty using the different models in here. And the measures of uncertainty actually, it would have said that you really don't want to call this election. All right. All right, so why did they not weight the data? Well, let's look at the 1932 results. The left is their unweighted. That actually looks pretty good, doesn't it? For the different states, it's not bad at all. The weighting doesn't seem to hurt much, but you can see why they would have thought, given their results in 1932, that maybe I don't need to use the weights in 1936. Let's go back another 4 years, 1928 election, where I'm using the 1924 who you voted for information. For this one, the weighting does make a difference, but the weighting corrects it. Right? Pretty much, except for a few states, the weighting corrects for that bias in the left-hand panel. And so here you have a method that the weighting works in 1928, the weighting works in 1932, and in 1936, I mean, it helps, but it doesn't completely adjust for the non-response bias. So if we revisit this poll, I mean, first of all, a lot of people criticize it for not being a probability sample. That's not true. It was a probability sample. It was a census. It was just from an incomplete frame. What about the weighting? The weighting worked well in 1928 and 1932. They also have additional information that they could have used for weighting. They actually recorded the postmark on every envelope that came in. And they could have used that in their non-response adjustments. Maybe they could have designed their ballot a little bit differently so that they would have collected additional information. They've been criticized for doing a census rather than a sample, which would have been more efficient, but that's not why they were doing the survey. They were doing this so that people would become familiar with their magazine, and so this was like a mass advertising campaign that they collected a survey as part of it. I think they could have combined it with other sources, maybe information about people who don't have telephones or automobiles, and that might have adjusted for the bias in there. But I think the main lesson from this is that it's important to continue to collect gold standard data. So to continue to invest in surveys such as the American Community Survey so that we have this kind of data that we have, can trust. And I think the other lesson is that we don't want to put so much confidence in our models for non-response. Because just because a model has worked in the past, there's no guarantee that that model is going to continue to work in the future. Right, so going back to Parten's list of the advantages and disadvantages of sampling, I think that if we modify our data collection and we make use of some of these multiple sources that are available, I don't see that we have disadvantages of the sampling. I think there are tremendous opportunities here to use our expertise in survey research to develop new tools, that we can use them to evaluate the quality of data sources. We want to produce faster, dynamic estimates. We want to be able to combine multiple sources through our design and in estimation. And I think the big one is that we really do need to develop better interval estimates for uncertainty. We have a lot of contributions, I think, to make. That if we do develop these new tools, we're going to have these timely estimates. They can be updated as new information comes in. We have the advantage that we have this expertise to take these samples, to do this sort of design, to do non-response adjustments. And we also have the shared values of our profession, the respect for the survey participants, and our concern about privacy and confidentiality and protecting their information. I think that if we develop some of these tools, we will be able to design our surveys using these multiple sources to get the precision that we want and save money by doing so. There has never been a more exciting time to be in survey research. Thank you very much.
Thank you, Sharon, very much, very much. Again, let's hold questions until the end, and please text any questions that you have to that number, but we'll wait until the discussants are done to take a look at the questions. Okay, so at this point, I'll turn it over to our first discussant, who is Rick Valiant. Let me load up his presentation.
Thanks, Brady. As Brady pointed out, I was a little late. I have an excuse, sort of. About 2:30, I jumped up to move my car over to the hotel at the corner of campus where the dinner is later tonight. So I, briskly walked back after I parked, and I got back to the office suite, and the front door was locked, and all the offices were dark, and there was nobody there. And I thought that this could be meaningful. So I looked at one of the hundreds of posters of Sharon, which are in her office, plus all over campus, and it's like America's Most Wanted. And I noted that the actual start time was 3 o'clock, not 3:30, which is what I had on my calendar. So at 2:50, I sprinted over here. And, so I'm happy to be here. We've got this kind of strange brew of data sources that we're expected to deal with these days. I mean, there are, things like Twitter and Facebook, Snapchat, web scrape data that people are asking statisticians to use and make inferences with and maybe combine with probability samples. And this is along the lines of things Sharon was talking about. How do we deal with all these things? The units that go with some of these social media sources are a little murky compared to what we like to have with probability samples. I mean, what's the unit of analysis with Twitter? Twits, maybe. How do you combine that with a sample of people where you've got data on individual people? There are bunches of these so-called big data applications now that don't quite fit in with what we normally think of in survey sampling, but they're still useful. I mean, there's an example that you can find that IBM has done on electronic health records, which are, they're not a sample of records, but they're a gigantic data set of electronic records. And you can sort through those and use machine learning algorithms and learn about the association of things like heart disease with other characteristics that people may not have thought of before. And it kind of points out a difference between what survey statisticians often do and data analysts. We like to have these well-defined finite populations to make inferences to. But in a thing like this, I mean, if you got a great big set of electronic records that covers a lot of different types of people, I mean, you can learn useful things without saying you're inferring to any particular finite population. Another one that IBM has done is just correlating climate and temperature with the spread of infectious disease. You know, they can kind of predict how things are going to move through tropical areas, for example. And it's not, it's a big data problem. It's not a survey problem, really. Another example that's out there is from the Long Beach Memorial Hospital in California. This was a single hospital where they had hundreds of records on doctors. And so they were able to sort through how these doctors were doing different things and identify the fact that some doctors were prescribing different kinds of drugs for the same conditions, and, you know, get in and make their performance more uniform. Again, there was a finite population, all the doctors in the hospitals. The units of analyses were repeated on each of the people. Now, the political campaigns have got into this big data analysis, you know, sorting through voter records and seeing, you know, who have they dinged for money and how many times, and have they given $2,500 already, and should we quit bothering them, things like that. You know, again, it's a big data problem. It's not really a survey problem. Now, in contrast to that is this thing called the Billion Prices Project. Anybody ever heard of this? It's at MIT. Yeah, the economists are raising their hands here. This thing is done by some economists who scrape the web for prices of different kinds. They put out price indexes for 22 different countries at this point, and they tout this thing as being a competitor for the US CPI, which is a, you know, quite expensive, well-designed probability survey of, it's a mesh of several surveys, in fact. You know, where people buy things, what do they buy, how much do they buy. BLS spends, you know, tens of millions of dollars on this, and the MIT, on the other hand, spends pennies, I assume, to scrape the web. So, you know, how do we deal with these things? How do we evaluate them? You know, Google flu and dengue fever data are out there. Is that good for anything? So it does bring up the issue of how do you integrate probability and non-probability samples together. The thing that I think we as statisticians and survey methodologists can contribute to is identifying cases where you need to define the population and say what you're making an inference to. You know, not be vague about that. You know, as you probably know, the probability samples became the touchstone back in early on. Neyman's article in 1934, JRSS, kind of laid the groundwork for a lot of the math. But you know, since that time, that if you could do a probability sample, then that's respectable. That literary digest debacle occurred after this, you notice, so they didn't read Neyman's article, I guess. Now, on the other hand, I mean, your best intentions can run afoul these days. Andy Kohut and some other people at Pew Research published some results that showed that in their phone surveys, these are not election polls necessarily, it's just all the sorts of phone surveys that they do, their response rate dropped from 36% in 1997, this is kind of an average rate, to 9% in 2012. Well, you know, you can start out with a probability sample of phone numbers, but you don't end up that way. I mean, you get a self-selected set of a coalition of the willing is what it amounts to. And, you know, people are worried about this. APOR had a task force on non-probability samples. There's just to show you that other areas are worried about this. There's an interesting article by Kiting and Tom Lewis in the JRSSA earlier this year about, it's called Perils and Potentials of Self-Selected Entry to Epi Studies and Surveys. So Tom, you may know, spent a couple years down at the Census Bureau as their resident expert, so he got tuned into survey issues. So he, you know, he's trying to integrate that sort of thinking into epidemiological studies. Now, as Sharon pointed out, the literary digest thing is a famous failure of polling, but it's happened more recently. In the British parliamentary election last year, this is not just one poll that was wrong, it was a whole series of them that were wrong. You know, they were calling, I think, too close to call, but Cameron's party won, you know, handily enough that they've got a majority in parliament. In the Israeli Knesset election last year, the same thing happened. Everybody was calling the competitor to Netanyahu's party as the winner, but Netanyahu's party won. Scottish independence referendum was called wrong by you know, any number of polling organizations. These were kind of a combination of attempted probability telephone surveys, volunteer web panels, you know, mishmash of stuff, but they were consistent in the sense of predicting the wrong outcome. And that, you know, that's a tough thing about polling, because you get this report card of whether you're right or not, you know, pretty soon, and people don't forget. You know, if we, in a regular survey, do a bad estimate of the prevalence of coronary heart disease, you know, you don't know that you're wrong for a while, and you may never know. Now, here's one that worked. This is kind of a famous thing now, I think. This Xbox survey, you know about this thing? The Andrew Gelman's been touting this for a while. There was this testy exchange in the New York Times between Gelman and Michael Link when he was president of APOR about the probability sampling being the right thing. And Andrew said, well, we had this Xbox thing with 345,000 people surveyed in an opt-in poll. And this was back when Obama was running against Romney. The composition of this Xbox group is totally out of line with the electorate. They, you know, 18 to 29-year-olds were 65% of the data set. The electorate is about 19% in that age group. They were 93% male versus 47% in the electorate. You know, this is a bunch of guys who live in their mother's basement and they never come out. And so, and yet, you know, through the magic of waiting, Andrew and his colleagues managed to call this right. So you know, the article here is 2015. So it's easier to predict the past than it is the future. This is a kind of a key thing here. You know, as Sharon pointed out, she was able to wait in a fairly simple way and take this literary digest data and get something that was more reasonable. So, you know, in probability sampling, we hope that all the things that we don't know about are kind of evened out by this random selection. If that is lost, then there's always this residual question of, could we have waved our magic waiting wand in the right way and gotten good estimates? And how do we evaluate that? So here's a picture that kind of sums things up, I hope. Think about an application where you have a voluntary panel of people who take web surveys. You know, these are pretty common these days. The YouGov has one that's got about 400,000 people in the US. Gallup has got one that's got, I think, up around 2 million worldwide. So, and these are, you know, there's money to be made selling surveys based on these panels. So suppose this is the big universe we want to make a inference to. This kind of orange square is the potentially covered people. These are people who have internet access, so they can take a web survey. Now, to get in one of these panels, you've got to typically visit a web page where, you know, a pop-up ad occurs and you can click on it and you get to be part of the panel, or you go straight to the Gallup website and say, I want to be in this thing. Mick Cooper in Michigan's in 7 or 8 of these panels, I think. Those are the covered people, you know, who they click on the ad and they go through the couple of steps to get be part of the panel. Then they select samples, which may be balanced. you know, on demographics. You know, they're kind of careful about that. They're like quota samples. So, you know, this is a vanishingly small part of the universe. Now that, you know, that doesn't necessarily bother you if you've got a probability sample. We can make inferences to the whole country, which has got 330 million people or so, based on a sample of 2,000. Brady's giving me the 5 sign. Okay. Now, in this case, though, if these are kind of self-selected people, the big issue is, do they look like all this vast uncovered space that's out there? That's what you lost or had no control over. Now, the missing data ideas are pertinent here. You know, missing completely at random, missing at random, which means you can adjust out the kind of the non-representativeness if you know enough covariates. And then non-ignorable non-response is the one that we always fear. You know, the reason that people got in the panel is related to the things that we're trying to measure. And that's very hard to assess and adjust out. So if we think about estimating population totals, those are easy, and it's easy to write down what's going on. The actual population total itself is the sum of what we saw in the sample. It's the sum of this covered frame minus the sample, plus the sum of the y's for this potentially covered part. You know, these are the people who've got internet access, but they didn't visit the right web pages or something. And then this, you know, this uncharted area out here that's not covered at all, people who don't have internet access. And as of a year ago or so, it was about 74% of households in the U.S. had internet subscriptions of some sort. So it's a, you know, it's a chunk that's not covered. So how do we predict for all these things we didn't see? You know, that's essentially the finite population inference problem. You know, kind of boiled down to this really easy case. So you can do one of two things. You can use a quasi-randomization approach, which means you got to somehow estimate the probability that a unit's included in the sample. So just based on that picture, here's all the things you've got to deal with. You got the probability somebody has the internet, probability they visit the web page given they got the internet, probability they volunteer given they got the internet and visited the web page, probability they participated given they got the internet, visited the web page, and they were volunteering. You know, that's a lot of stuff to try to estimate. And, you know, you may be able to estimate a product of these all at once, which is done sometimes with things called reference samples. You know, they try to draw a decent probability sample, and then they throw their volunteers in with the reference sample and estimate propensities of being in the sample. And I don't think that works, but that's what's done. You could predict with superpopulation models. So what it amounts to is you got to put a hat on all this stuff you didn't see. And so I did it right here. From that point of view, it's possible. But whoop, back. I'm getting too excited here. You know, you can make a model, or you can suppose a linear model is what you want to use. Linear models allow predictions. In the simple case, all you got to know are population totals of your covariates to construct this. But the big issue, as Sharon pointed out, is bias. Is your prediction for, say, this piece any good? Maybe not. You know, if you got a bunch of omitted covariates, it could be terrible. You know, there are basic problems with these linear models. If Y is binary, you're predicting a 0, 1 with a linear model, but we do that all the time in surveys. You know, we have weighted sums of the zeros and ones we observe. That's implicitly you're using a linear model when you do that sort of thing. Another big issue for some people is every Y may have a different model, true enough. What you want to do is pick a set of covariates that's good for a whole bunch of y's. That's the same sort of thinking that's done when you construct a general regression estimator or another calibration estimator. I mean, it ought to be done in every survey. I don't think it is much of the time. And undercoverage is a huge thing. You know, all that, you know, there's people who didn't have internet access, for example, who didn't visit the web page. That's a kind of undercoverage. So you're implicitly adjusting for that, whatever you do. And the question is, are you doing a good job at that? So how do you make a good model? You need to select good covariates. All these machine learning algorithms seem like they're good things to think about. Lasso cart, random forest boosting, there are some other ones. They may be limiting as a practical matter because you may not know the individual covariate values for all the non-sample cases. So you need to work around that. I think that's possible. Jill Deaver and I have done a few things. You need a whole bunch of covariates is what it amounts to. Let's see. Another huge issue, I think, is proving that the model that you choose holds for the non-sample. You know, we need diagnostics for that. Is it even possible to construct diagnostics that will tell us? Balanced sampling, there is some theory for this. I'm not sure how useful it really is in this case, but it's in this book. Now, just to wrap up, you know, we still have a role to play despite the fact that it's very hard to draw these probability samples and keep them that way. I think one of the big things we can contribute is choosing data sources, which Sharon alluded to. You know, there's a lot of possibilities out there. How do we put them together in a sensible way these days? You know, can we use Twitter, Facebook? How do we define the population? When do we have to define the population? You know, if you're working with a client, when do you need to sit them down and have the population talk with them so they'll understand what they ought to be doing? Measurement is a big issue. You know, if this is a kind of a methodological thing, are different sources measuring things the same way? I mean, this is kind of crucial that we equalize those if we're going to put them together. Excuse me, estimation is a kind of a tail end issue. How do you deal with these volunteer panels? How do you combine non-probability and probability samples? Do you use these dual frame estimators that Sharon was talking about? Can you lump everything together, fit a single model that makes sense? To me, models have got to be used in this new world we're in. And design-based inference is just marginally useful at this point in a lot of applications. So there's kind of different levels of this stuff. I mean, official statistics, it seems to me, are an example of a case where you really need to do things the old way as much as we possibly can. Draw nice probability samples, make sure you cover the whole population correctly, make sure you got a complete frame. In other cases, maybe you can get by with a lot looser kind of formulations. But you know, these are important statistics here. The unemployment rate, inflation rate, new job creation, prevalence of health conditions. These I think we need to do a good job on. You know, if we miss the call in the primary in Michigan, yeah, you know, it doesn't seem important to me. Now, how do we do it? It's a mystery to me, but all you students can figure that out, I'm sure. Thank you.
Okay, now I'd like to welcome up Cynthia Clark for her comments and her discussion.
Well, it's an opportunity for me to be here and to give you some different perspectives on what Sharon and Rick have talked about. Rick actually gave me a nice entree because I have spent all my career in official statistics. So I'm going to take a look at some of the problems that official statistics are facing in relationship to doing surveys. So Sharon talked about some of the issues in surveys. She talked about the decline in response rates, and she talked about wide access to large data sets. And there's, of course, another issue that's kind of tangentially related. It is the lack of public knowledge of the role of official statistics. People don't always know what is an official statistic and what comes from these other data sources or non-probability surveys or other types of estimates, forecasts, predictions. So I'm not going to talk too much about that, but that's just kind of going around in the background to what I'm going to say. She argues that the skills of survey statisticians will still be needed, and she discusses some additional skills that are required. And I'm going to give you some probably more additional skills that might be needed. One of the things that I'd like to just spend a little time on is discussing new laws affecting statistical data collections. This goes to the response issue that you have with surveys, and as Rick mentioned, some of the things, probably much of what we talk about in official statistics is survey-based and relies on having relatively high levels of response. Now, most surveys, official statistics surveys, are voluntary. You may not know that. There are only a few that are mandatory. You have the population census. They've been able to keep the American Community Survey mandatory, but it's faced a lot of protest on that from the Congress. There are some the economic and agriculture censuses are mandatory, and a few related surveys and principal economic indicators tend to be mandatory. Now, even when they're mandatory, you don't always have 100% response. And most of the official statistics agencies don't really do anything about it if you don't get response. They don't prosecute, although they could. So, but they still note that they aren't getting 100% response. Well, there's several new laws that are affecting data collection. So I'd like to just spend a few minutes mentioning each of those laws. And they also affect some surveys that do not produce official statistics, but are done by contractors, or official statistics done by contractors. So the first one kind of hit people by surprise. It's the Cybersecurity Enhancement Act of 2015 was actually put onto the budget for 2015. And what it does is it establishes cybersecurity-related requirements for the federal government to improve federal network security. But what it does is it allows access to federal statistics, even though they're protected by a law referred to as SIPC. And in fact, just mention up there, but the Secretary of the Department of Homeland Security may access information notwithstanding any other provision of law. So this, as you may know, all federal surveys carry a confidentiality pledge if they are protected by SIPC. And the federal agencies now are looking at what they can say about confidentiality on their surveys. This does have one limitation. It relates to data that comes in over the internet. So data that would be collected in person would fall outside of this, telephone or person. But as you know, we've tried to move to web data collection for many surveys. So it's very scary in its implications for survey data collection and for the issues of non-response and non-response bias. So, I've mentioned that we might have to change our statements. It's likely to decrease response rates, and it's likely to affect different groups differentially. There's another act called the Federal Information Technology Acquisition Reform Act, which is FITRA, which does have a clause in it which allows government agencies to protect, but it really depends within departments how it is handled by the information technology component of the department. So even though there is OMB guidance on it, some departments are facing a lot of difficulties with their IT department in order to protect the data. There's another one called the Telephone Consumer Protection Act, and it includes federal statistical agency contractors in a prohibition against surveying by cell phones without prior consent by the respondent. So that also has an implication on response. And it increases the cost to agencies and to contractors. There's another one that has a different potential that could be a little more positive. This is an act that is being discussed, and we're yet not there. It's goes back early in my career. I worked on something called the Data Enclaves legislation, which was in the 1980s, and they were trying to get data sharing among the statistical agencies and broader use of IRS data. This is working with a synchronization of data which could be achieved if IRS provided the same business data to the Bureau of Labor Statistics as is provided to the Census Bureau, so that the registers that are kept or the frames that are kept by those two agencies could be more in sync. I will just say, sort of off the cuff, I'm on the Committee on National Statistics panel for re-engineering the Census Bureau's annual economic surveys. And one of the things that they're looking at is re-engineering their business register. And we have discussed the possibility of suggesting that they might talk with BLS and try to get the registers more in sync in terms of what they're collecting, so that if something were to happen, they would be more better positioned to do something. So I think, well, right now, because this is a proposal, they've asked these departments to consult with stakeholders and to develop language for a bill that would permit this. Well, it appears that with the issues that we've talked about with non-response, and which the issues that Sharon and Rick talked about with big data, that we need to rethink the survey paradigm. Maybe I should have said the official statistics paradigm, to think a little more broadly about, well, what can be done with big data? What big data sources can be used productively and I'm speaking particularly in official statistics, which ones aren't. And I will give you a couple examples in a few minutes. And can those work with current procedures, or do we have to change all of our procedures? How do we go about changing this paradigm? In official statistics, you're very interested in time series. You're interested in what happened before and what happens next, and you want to relate what's happening now to what happened in the past. If you change your whole mechanism, then that becomes very difficult. How do you measure quality? And what measures are relevant? Well, we talked about a measure of uncertainty, and that seems to be really a basis that we're very interested in as statisticians. And then again, what is the role for surveys? And then how will society view official statistics versus other available data? And how do you differentiate that data? Well, I mentioned that there are some current examples of big data in official statistics, and Sharon and Rick both talked about models that use both survey and administrative data. And in my term at the Department of Agriculture, that became very apparent that we needed to move for models for crop estimates and for county estimates. For many of the estimates moved to model-based estimates, and we also had some other data sources that weren't publicly available in agriculture. You had program data that was available through farm programs, and you also had geospatial data, and you had climate data. Just this week, or last week, I heard that Statistics Canada had produced crop forecasts using geospatial data. And I took a few minutes to go to their website and see how they were presenting this. And they did a very nice job of explaining their methods and their procedures. They used vegetative index data, satellite vegetative index data. They used field crop reporting series, which was something that came from a survey base, and they used climate data. And they were still also publishing their survey data, but they were using their survey data. They were getting yield estimates from their model, and they were getting harvested acreage estimates from their survey, and they were getting their production by the product of those two. So it was a very interesting way of presenting, and they talked about their methods and their quality. So you can check that website out and look at it. A while ago, I was on the Statistics Netherlands Advisory Committee, and they once presented something that they were doing using traffic monitoring data and seeing what they could do to produce some official statistics. They also did some web scraping of airline flight costs, and we're trying to come up with some indexes from that. So what are the skills that are needed in federal statistics? Well, I came up with a lot, and Sharon added to those more specifically in the survey side, but have more data analysis needs. You definitely have missing data and dirty data. You have statistical model building, and that to me seems really big, and small area estimation is just one piece of that. Record linkage, where you have data that you're combining from multiple sources, becomes very, very important, and probabilistic record linkage. Disclosure avoidance continues to be an issue. The broader range of statistical methods beyond survey statistical methods, I think, are something that we might want to be looking at in the survey world. And of course, enhanced computer skills and capabilities, and enhanced communication with the public about what we're doing. So the issues that a federal agency must face is their continuity of estimates and procedures. I talked a little bit about that a bit ago. Public cooperation in surveys. How are we going to keep the public engaged? How are you going to reduce the non-response bias? And then public acceptance of new methods. And how you present those new methods in relationship to the other data that is so easily available to the public on the internet. And of course, greater need for communication on roles of official statistics in public and private decision making. So what are our challenges? Well, addressing the response issues and biases, evaluating and combining multiple data sources, and developing appropriate measures of uncertainty. So that's it.
Okay, so a wonderful series of talks. I think we should give all of our presenters one more round of applause, definitely. Thank you all. Okay, so at this point, we'll do some question and answer. We have a microphone here, and I'll just walk around if anybody has questions. I didn't receive any questions via text, so hopefully everybody was actually watching the YouTube stream. But if anybody does have questions, please do go ahead and text them. Otherwise, I will go grab the microphone, and then I'll pass the microphone back and forth for people who have questions. So, okay? Okay, anybody want to kick things off? Okay. And go ahead and say your name and where you're from and who you're directing the question to.
Lugers are from Westat. This is actually for all of the presenters. It seems that there are these bad polls, these disastrous polls, but it seems like, rather surprisingly to me, most of the polls seem to get it right, actually. With response rates, the difficulties of people, the polls actually, most of them seem to be getting these primaries, for example, correct. Very surprising to me if any of the speakers have any insights on what might be going on.
Who wants to take that out first? Rick claims luck, okay.
These polling firms do a number of things. I mean, they try to make some likely voter adjustment. So one of the things that they tend to ask is something along the lines of how likely are you to vote in the coming primary or election. And, these are just sort of propensity models. And I don't know that they've ever had any way of evaluating those. You need to have a follow-up study to see did they actually vote or not, to see if your predictions are any good. This is one thing the polling firms worry about a lot. Pew Research is, I know, concerned about this. I think that it must be, if they're getting it right, that these post-survey adjustments, they rake to as many things as they pertinent, must be doing fairly well. As the underlying model that is implied by what they do must be fairly reasonable.
Okay, Sharon passes. Oh, Cynthia passes too. Okay. Okay. Who has any other questions? Okay. Just hold the mic close to your mouth too.
Hi, Keith Rust from Westat and JPSM. I guess this is for all the presenters, but it was really motivated by something that Rick presented with his little diagram breaking the population into these four groups. And the statement you made that, well, if you have a 9% response rate to a probability sample, that's no better than a non-probability sample. And I think a lot of people don't quite buy that, and I think maybe it's because they're worried about that U minus F part that you were talking about, that the propensity for a lot of people in that cell is like 0, or we don't have the variables that would predict usefully for that group. And I just wonder if anybody has any response to that. Do we really think that a probability sample with 10% response rate is absolutely no better than a non-probability sample, or is there reason to think there's still some benefit to that?
Yeah, I tend to agree with you. I think that if you get, take a case where there's really an underrepresented group in some of these polls, like 18 to 24-year-old Hispanic men. Those tend to be really short in these polls. Or 70-plus-year-old black women. There's two issues. Will they vote? And if they do vote, can you use what few people you got to project to the ones that do vote? So if you had no chance at all of getting any of those people, you're just out of luck, assuming that they behave differently from everybody else. If the way they vote is predictable from everybody else in your sample, then you're okay. So that, I guess the advantage of probability sample is you had some chance of picking up a few of them, and you just got to pray that you actually did.
If I could, because he and I were both at this workshop at Johns Hopkins, the symposium at Johns Hopkins a week or two ago, the Ross Royal Symposium, and there was a lot of discussion there of probability and non-probability samples, and I can't remember who it was, so maybe Rick can help my memory, but someone, maybe it was Andrew Gelman, who, by the way, was extolling the virtues of data from the last election, which Sharon used, which is kind of cool. But somebody said one of the advantages of probability samples is that in constructing the probability samples, people have thought very hard about the subject matter and kind of understand what's going on, and that gives them maybe a little bit more ability to adjust for various types of missingness and also to do estimation. Rick, did I get that?
Sharon or oh yeah, that was Nat. Yep, Nat Schenker. Sharon or Cynthia, did you want to comment on Cynthia? Okay. Please. I think somebody needs to direct a question at our distinguished lecturer. Okay, Nat, go ahead.
I think one of the things that I've heard sometimes about Nat Schenker, National Center for Health Statistics. I think I've heard that one of the things that sometimes distinguishes fitness for use with things like big data versus the kind of probability samples that we tend to use in the government is, the estimation problem. The agency had met with President Obama's, data science person. And he was talking about how in some cases in business, the signal is just so strong, you don't need a really precise measure. You get an indication of where things are going. Whereas, as I think you were mentioning, in government, we're tending to want to estimate things very precisely and without bias for policymakers. So I'm not sure if this is a question or a statement, I'm sorry, but I was just wondering do you think maybe government might get into some of those kinds of problems where big data would be more fit for use, or do you have anything to say about that? This is addressed to Cynthia.
Well, yeah, I've heard the fitness for use, though that's really a difficult thing to work with. And I tried to stay away from that as much as possible because there's no real criteria to know whether it is fit for use.
Okay, yep. Frauke has a question here.
JPSM. Sharon, I really enjoyed your talk, and at the end you were talking about the need of better measures of uncertainty that capture the camel, basically, right? And I mean, certainly it becomes even more prominent with these alternative data sources, but we have been talking about this for quite a while collectively. What is your take? Why haven't we gotten any closer to that?
That is a really good question. And if you go back to the early writings about surveys, so, like Parten's book, Bowley's writings, I mean, they're still raising this same question. I mean, in Deming's book, he's talking about that the reason he's advocating for probability samples is because those are the only ones for which we know how to calculate the measures of uncertainty. And he says that basically if you have a judgment sample, there is uncertainty, but we don't know what to do with this. And so I think, this has been a hard problem for a long time. But I think we need to be the people who look at this, because there are a lot of people who are looking at some of these alternative data sources, and they're producing estimates, and their estimates don't have any measure of uncertainty with them at all. And they are uncertain. They do have bias. They're not capturing everything. And so I think the reason nobody's done it is because it's a really hard problem, and it depends on things that we don't necessarily measure. But we do have a lot of advantages now that were not there when Deming was writing his book. And one of them is that we do have all of these multiple sources of data. We might be able to use those to evaluate uncertainty a little bit better. But I think we need, just a panel of statisticians and a consortium to kind of come up with some answers for that.
Okay, question in the back. Joe.
Not a question. This is Joe Sidransk, ex-editor of JSSAM. Somebody commented before about, a short while ago, about why predictions were, election predictions were on the whole good, and particularly about turnout. Turnout bias is the subject of an article in the current issue of JSSAM. Scarini and Goldberg. I suggest you might want to, it's an interesting article. Of course, it's based on a Swiss survey where they had access, as in Europe, to population data through the registry. My second answer to part of this is I'm not a political scientist at all, but I know lots of them, and I know that there are a lot of people working on the problems, analyzing ANES data. And so I think in general, I'm not talking about the political polling. I think there's an enormous amount of variability. But if you took a set of polls, election polls, some of them are pretty crappy, but a lot of them are quite good. There are just a lot of people working on the problem. Second, this is totally different. So at any rate, there's a JSSAM article. The other comment is of the government statistics. As I was listening today, I think there's one of the government things that non-prob sampling that really appeal to me is the billion price index at MIT, and I'd be really glad for comments because I think that's quite different than some of the other ones. That the problem of getting prices and amounts it's very, very widespread, both in terms of the people producing the prices and the sets of places where the prices occur. And that might be a place where, in the official statistics, which had the most promise as far as so I'd look some comments from that.
Would any of the presenters like to speak to that? Yep, right.
I wanted to say something about the billion prices comment. I mean, Catherine Abraham is here. She's the ex-commissioner of BLS, who probably knows more than I do. But the CPI is not just a finite population estimation problem. There are a lot of economic adjustments to the prices in there to account for things like quality changes over time. You know, you may pay the same amount for a computer
this year as you did last year, but it's quite likely you're getting a better computer this year because the hard drive's bigger, the processor's faster, everything about it is better. And BLS makes economic adjustments to account for that. So if you scrape prices off the web, there's a big issue about getting enough information on the quantity itself to make these adjustments. And then there are other things too, like rental prices, where the BLS imputes for homeowners. They don't use the price of sold homes. They use the rent that a homeowner would have paid if they had been renting that dwelling, and that's a kind of an economic calculation that it's not just scraping prices off the web to get that. So that CPI is a complicated thing that would be tough to replace, I think, with easy to get data.
One right here.
Hi, I'm Jean-Michel Tremblay from Civil Engineering. My question is for Sharon Laura. So you talk about this 1936 election date, and you said that you did your own analysis with weights and everything. You said that basically you wouldn't make the call about this. So my question is, I feel like nobody assessed that, is when should you just give up on some modeling approach because you feel that it's not reliable enough for your purpose? I feel like nobody ever, we address model selection, variable selection and everything, but we don't address where at some point you just think that the data and the problem just can't be matched, or at least you don't know how to, and you should just report this. So.
And we'll have one more question after this, and then we can continue in the back of the room.
I think that's a really good question, and I guess I would say that we don't give up, and we don't say we can't do it, but we have measures of uncertainty that reflect that we don't think that these are very precise estimates in there. To follow up on Joe's comment about the polling, one thing I did when preparing for this lecture is I went back and I read a lot of the things that were done in the post-mortem for this survey. And there was an article in the Literary Digest that said what went wrong with the polls. And then I read the postmortems of the surveys for the Iowa caucuses and for the Michigan primary. And it was really interesting. You could probably have taken the Literary Digest postmortem and just pasted it onto these other things, because they said exactly the same things that they said in 1936, right? People changed their minds. We didn't sample close enough to the election. We didn't have everybody in the frame. Not everybody responded to the survey, and we don't understand why even in the places where we got 4 out of 5 voters, the 1 out of 5 who didn't return our ballot was apparently always a Roosevelt supporter. So I thought that was quite interesting that the problems are, basically still the same for these.
Okay, let's do one more. Yep, one more, and then we'll adjourn here.
My name is Hyun-Sik Lee from Westat. I just want to make a comment about this design-based approach versus model-based approach. We survey statisticians cherish that design-based approach is more robust. Not only we are able to calculate the uncertainties, but I think one big advantage of design-based approach is the robustness. But I guess we more and more have to rely on the model. We cannot, do it without it. So the big challenge is, I think, how to check the model. If the model is wrong, even though it can give a good answer, the answers can be quite wrong. So I think big challenge is the, how to check the model.
Any additional reaction to that, or? Okay, well, let's thank our speakers again, and if you have additional questions, feel free to ask in the reception right now. So.